Good afternoon, everyone. My name is Afiyah Huang, and I am from U63. Today I'm going to share with you what I believe to be the most world-changing idea. Now, I know that there are many countless ideas out there, but why did I choose to talk about the induced pluripotent stem cells? Hopefully, by the end of my talk, you'll find out and realize why too. Maybe you might even share the same thoughts like mine. Before I go deeper into the iPS cells, what is a stem cell? A stem cell is a class of undifferentiated cells that are able to differentiate into specialized cell types. Like in this picture, you can see that this one stem cells can differentiate into the muscle cells, the skin cells, blood cells, and many more. Now, many years ago, before the introduction of these iPS cells, doctors, scientists have experimented on two different types of stem cells. The first one being the embryonic stem cells, which are taken from the embryos. These cells are known to be totipotent, which means that they are able to divide into any type of cells. But because these embryonic stem cells being taken from the embryos, it has raised a lot of ethical issues. Now, the second stem cells is the adult stem cells. These adult stem cells are taken from the bone marrow located at the lower back of your body. These cells are known to be multipotent, which means that they are only capable of giving rise to a limited supply of cells. Now, these two Japanese doctors named Dr. Kazutoshi Takahashi and Dr. Shinya Yamanaka, they have experimented on cells like the human skin cells and the blood cells. They have injected many genes into these cells. Before I continue, what is a gene? A gene is a part of cells that controls or influences your appearance, your growth, and many more. Initially, they have injected and experimented with 24 different genes. But using 24 genes could be very difficult and troublesome, so they have narrowed it down to only 4 types of genes. What are these 4 genes? These 4 genes are the OCT4, the SOX2, the CMYC, and the KLF4. They have done another experiment to see which genes are the most important in doing the iPS cells. And they have discovered that the most important cell that they need are the SOX2 and the OCT4, while they could change the KLF4 and the CMYC into these 2 different genes, which are known as the NANOC and the LIN28. So by injecting these 4 genes into the human skin cells or blood cells, they are able to produce these iPS cells. Much like, as you see here, is a bread. You can imagine this bread as the skin cells and cookies as your blood cells. So when you add 4 different things, you can revert it back into a dough to make other new stuffs. So, what really is iPS cells? iPS cells comes from changing a differentiated cell back into an undifferentiated cell. It behaves like the embryonic stem cells. And it also is used to develop into specific cells needed to replace the bad cells. However, these iPS cells will only potentially work with diseases that comes with a malfunction of only one type of cell. Examples of these diseases are the Parkinson's disease, the blindness, heart failure, spinal cord injury, liver failure, diabetes, anemia, and joint disorders. Now, over the past years, they have released several articles to show the success of these iPS cells. And I will share with you the findings of Dr. Masayo Takahashi, who has experimented these iPS cells on a real human being. So she experimented this on a woman who is in her 80s. This woman has an age-related macular degeneration. Age-related macular degeneration means that this person's eyesight is getting worse. Now, she treated this lady with the iPS cells. And the cause of this age-related macular degeneration is the malfunction of its retinal cells. So they tried to develop these iPS cells into a new retinal cells, and they have replaced the new retinal cells with the bad one. And it is a success. The lady has said that her eyesight even got better. So in conclusion, what I'm trying to say is, from the two earliest matters, which is taken from the embryo and the adult bone marrow, this could be a very good alternative in medicine. Instead of sacrificing the poor embryos, waiting for adults to donate their stem cells from their bone marrow, they could just develop these in the labs without having to harm anyone at all. And with that, thank you for listening.
That was a lovely presentation. Congratulations.
Thank you.
So you talked a lot about the advantages of using induced pluripotent stem cells. Like that of the embryonic, there are disadvantages, right? Mm-hmm. What are the limitations to using these cells?
Well, I think that because everyone is different, right? They're taking the skin cells and the blood cells from some other people and they get injected. So when you use other people's donated skin cells and blood cells, it might not be capable to the person who are receiving them.
Okay. So what like similar to my Chibu Hajasriani's question before, what recent discoveries or what recent work has been done on this? I mean, you talked about the retinal cells. Mm-hmm. Is there anything else?
Well, this is the most recent findings. The old ones were the embryonic stem cells and the adult stem cells. And actually, this research, they have halted it, they have stopped it from experimenting on humans because they are scared of the side effects. But here I'm trying to encourage the experiment to be continued and to be long.
So when you say side effects, is that what you said before, like rejection
yes.
to the skin cells? All right, okay. Thank you.
Thank you, Afiyah. Well, stem cell. Okay. Talking about the side effect, yes. You mentioned rejection, but I think one of the important side effects is the development of tumor, because stem cell in the lab you can control the development of genes or cells by on and off the genes. But once you insert it or introduce it to our body, it is totally impossible to off the genes in malfunction. But my question is, if you're a seller or you want to develop this technology, how would you convince us? Thank you.
I would convince this in a sense that I would compare it to the old ones, and I would talk about how the embryonic is bad because embryos are undeveloped babies, right? And when you take the stem cells from these undeveloped babies, they might not be able to develop into a real baby, which in other words seems like killing the unborn babies to other people. So it's very bad. And for the adult stem cells, the process of taking the stem cells from the bone marrow could be very painful, and not everybody wants to donate. So I would convince people that this is the best way out of the 3 ways, because you just have to develop into, while convincing other people that there might be side effects too. But before giving them this treatment, I would have presented them with the contract that they would fully know of the side effects, and they have agreed to this treatment. Thank you.
Let's compare with a very recent method other than IPF. We have gene therapy. How would you compare this to gene therapy?
For gene therapy, they have, I think they have the gene rejection. Sometimes the gene, they are not compatible. The gene therapy are not compatible with some of the patients. I'm not quite sure myself about the gene therapy, but what I have known is that they have tried it on some people, and then some people, they rejected the therapy. The therapy didn't work on them because of their immune response to the gene therapy. And for this one, Dr. Shinya Yamanaka has talked about how it has overcome the immune response, how it has a higher chances of people able to being treated with this treatment. So I would suggest this one instead of the gene therapy. Thank you.
Okay, hold on. I'll ask you a question. Okay, so Afiyah, first of all, I'd like to commend you on the technique that you had used. And I think the audience also enjoyed the analogy of that bread and cookie, right? Yeah. And they got it, I can hear it, and I got it as well. So I'd like to just ask, actually, because I seem to see that most of the references that you had here were related to Japanese doctors.
Yes.
And I just wondered if there were other studies on this being done outside of, because there were just 2 doctors, the 3 in total, outside, apart from them, probably from other countries, or I would like to have another example as well, apart from the 80-year-old lady as well.
Dr. Shinya Yamanaka had went to a conference in America, and he has talked about and introduced these iPS cells to the Americans. And this one doctor named Dr. James, he was very interested in the whole talk, and he was very interested in this idea. And he wanted to collaborate with Dr. Shinya to go more in depth, to experiment, to learn more about these iPS cells, and he wants to open it up in America too, so that this iPS knowledge is spread worldwide. As for another example, there was it's not actually on humans, but it's on mice. The mice had one specific disease. I don't remember what was it, but they have injected this iPS cells to the mice, and then out of, I think there was 10 mice. Out of 10, around 5 was successful, while the other 5 was not, unfortunately. But yeah.